So here's a quick question. Where's the biggest stash of gold on Earth? Well, thanks to the movies, my first thoughts go to Fort Knox, the iconic U.S. vault known for its security and secrecy. But no, that's not it. Potentially, more than 99% of Earth's gold might not be in any vault. It's likely hidden deep inside the planet, in the core. And now, scientists say we might not need to dig 1,800 miles to get to it, because some of that gold, it might be making its way up, oozing through a volcano. But first, what makes gold so interesting and valuable? Well, gold has always been more than just a shiny metal. It's shaped economies and driven empires. The first pure gold coins were created in 540 BCE by King Croesus of Lydia, an Iron Age kingdom located in what is now modern-day Turkey. As a metal, it's rare, but not too rare. It's a great conductor of electricity and heat. It doesn't rust, tarnish, or react much with anything. It's easy to melt, mold, carry, and measure. And on top of all that, it's beautiful, durable, and incredibly useful. Not just for jewelry, but also in electronics, medicine, and space tech. Yep, it's even used to coat astronaut helmet visors and spacecraft to reflect harmful infrared radiation. Humans have mined about 200,000 tons of gold, which is enough to make a cube that's roughly 72 feet on each side. Since gold doesn't really break down, a lot of the gold we use today could actually be really old, even dating back to prehistoric times. It's also one of the most hoarded and secretly stashed valuables on Earth. Between private collections, national reserves, and heirloom jewelry passed down through generations, we might never know exactly how much is really out there. But we do assume that 99.99% of it is still trapped within Earth's core. So, how can there be gold within the core, and what does that mean? Right under our feet is Earth's outer skin, the crust. It might feel solid and massive to us, but compared to the rest of the planet, it's paper thin. Beneath that is the mantle, which is basically a giant layer of hot rock. It's not quite solid, not quite liquid, more like a slow-moving putty that flows over time. Then we have the outer core, which is a swirling sea of molten metal, mostly iron and nickel. It's spinning around and creating Earth's magnetic field. And in the very center is the inner core, a solid metal ball hotter than the surface of the sun, but still solid because the pressure down there is extremely high. When Earth was first forming, it was super hot. So hot that the entire planet was like a giant cosmic lava lamp, bubbling with molten metal and rock. In that state, every element could move freely, and the heaviest one sank toward the center. Gold, along with other dense metals like platinum and ruthenium, is really heavy, so those metals naturally sank to the core in a process called planetary differentiation. Think of it like oil and water in a bottle. If you shake it and then let it settle, the heavier substance sinks to the bottom and the lighter one rises to the top. In Earth's case, lighter materials floated upward and eventually formed the crust. Now gold has a really cool characteristic. It really likes to stick to iron. That's why scientists call gold a siderophile, which literally means gold-loving. Ooh. So when iron started sinking, gold followed it down, straight to the center of the planet. On top of that, gold is super heavy, nearly 20 times heavier than water. So gravity helped pull it even deeper. That's why today, the Earth's crust only has tiny traces of gold, while the other 99% remains unreachable in the core, 1,800 miles below our feet. But that's not all. Some theories suggest that maybe 200 million years after Earth was formed, the planet got hit by a bunch of metal-rich meteorites. Those space rocks were loaded with gold, and since Earth's crust had already cooled by then, that gold stayed near the surface, and we've been using it ever since. So if most of Earth's gold is trapped below, what exactly was discovered oozing out? Well, scientists recently studied volcanic rocks in Hawaii. and they found out that these rocks contained a rare version of the element ruthenium, which is called ruthenium-100. Now, this little isotope isn't something you usually find hanging out near the surface. It has a kind of chemical footprint that says, "Hey, I came from way down deeper." And when we say deep, we mean core mantle boundary deep, the layer where Earth's molten metal core meets the rock above it. Basically, it's the basement no one thought you could access, the basement where we assume that gold is hiding. So how did these rocks get from the core all the way up to Hawaii? Vacation! Well, no. Actually, it all comes down to something called a mantle plume. We know that the lower part of Earth, near the core, is insanely hot. Every now and then, a big, superheated blob of rock starts rising through the mantle, slowly, like really slowly. We're talking a few inches per year, but over millions of years, that adds up. This rising column of hot rock is the mantle plume. It doesn't blast upward like a volcano. It slowly rises and carries material from deep inside the Earth. That includes elements and chemical fingerprints from the core mantle boundary. However, here's the cool part. When that plume finally reaches the surface, it punches through the crust and creates a volcanic hotspot. That's what happened in Hawaii. The islands were literally built by this deep Earth plumbing system. The lava that erupts there isn't just melted surface rock. It's a blend of material that's been on a journey from thousands of miles below. But I can hear your thoughts now. Wait, what about gold? Well, sadly, we're not talking about gold bars coming from a volcano. What's actually leaking is tiny atomic-level traces of metals like ruthenium. However, where there's ruthenium, there's a good chance gold is tagging along. Remember when we said that gold is a siderophile, meaning that it really likes iron? Well, the ruthenium has the same property. It's an iron-loving element, which means it tends to bond with iron and sink to the core during planet formation. So if ruthenium from the core is managing to ride up to the surface through mantle plumes, it strongly suggests that gold and other similar heavy metals could be doing the same. In other words, scientists are using ruthenium as a chemical trail marker because it's easier to detect and analyze, meaning that gold might be there too, just in amounts too small to measure with current instruments. This discovery suggests that all the siderophile elements are leaking out of the core. But this opens an opportunity to ask, has this happened before, and if so, what could it mean? Well, maybe Earth's core has been leaking metals all along and we just never noticed. The truth is, we're still just scratching the surface, or in this case, the core. For all we know, this kind of deep Earth leak has been going on for millions, maybe even billions of years. But until now, we haven't had the tools to notice. The technology that scientists use to spot ruthenium-100 is brand new. It has only recently become precise enough to pick up these tiny chemical hints. So this might be the very first time we've caught Earth's core doing this. And if that's true, it's kind of a big deal, because it means the inside of our planet isn't sealed off and silent. And it might still be shaping the surface in ways we never imagined. Not with explosions and earthquakes, but with slow, steady, atomic-scale signals rising through the rock. We're only just beginning to detect these signals. And if rare metals are making that journey upward, there's a lot more happening deep inside Earth than we thought. This isn't just a one-time discovery. It could be the start of a whole new way of understanding our planet. Cool, huh? Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campiflagre, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campiflagre erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campiflagre has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campiflagre is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
You type Tonga Cliff Mystery into Google and this pops up. A rock. Yep, just a rock. At least at first glance. But it gets weird once you realize this is actually a 2-story tall boulder perched on top of a 120-foot high cliff in Tonga. And it's chilling there, at a whopping 128 feet above sea level. So, how the heck did this rock get there? First, a proper introduction. This is Makalahi, which means big rock in Tongan. This name hits the nail on the head because this baby stands at about 22 feet tall. That's taller than a giraffe standing on its tiptoes. And it weighs over 1,300 tons. And that's like stacking nearly 325 elephants on a giant scale. With those massive measurements, it makes total sense that the locals call it Makalahi. But from now on, we can also think of it as the giant tsunami rock. And to understand why, I've got to tell you the story of Makalahi in Tonga. In 2024, researchers from the University of Queensland's School of the Environment were exploring the southern side of Tongatapu Island. One day, they were chatting with a group of local farmers who mentioned a strange and massive rock sitting up on a cliff. And they were honestly pretty surprised. After all, it didn't make any sense for such a huge boulder to be located that far inland, especially since it's sitting about 656 feet away from the edge of the cliff. On top of that, it was covered in vegetation and surrounded by overgrowth, which suggests it's been sitting there for a long, long time. That's when they started asking themselves the big question: where did this rock even come from? So to figure it out, the team created a 3-dimensional model of the boulder and headed to the coast. After some careful research, they finally found the spot where the boulder could have originated. Turns out, it broke off from a cliff more than 90 feet above sea level. Alright, so they found the source, but let's take a moment to recap what we know so far. The rock originally came from a spot about 98 feet above sea level, and now it's sitting at 128 feet above sea level. That's a pretty big jump. Sure, it's not like climbing Mount Everest or anything, but come on, it's a rock. It didn't just grab some gear and climb up there by itself. That brings us back to the big question. How did this massive boulder get up there? Well, it was probably moved by a tsunami. Yep, this rock could actually be solid ancient evidence of a tsunami. You see, we're talking about Tonga, an island country in Polynesia, part of Oceania. It's made up of nearly 170 islands with about 36 of them inhabited. The country is divided into 3 main island groups, the Vava'u, Ha'api, and Tonga-Tapu archipelagos. The entire region sits right at the junction of 2 major tectonic plates, the Indo-Australian plate to the west and the Pacific plate to the east. It's part of the Pacific Ring of Fire, that giant horseshoe-shaped zone that wraps around the ocean basin. And if there's one thing we know about the Ring of Fire is that it's packed with intense geological activity. With lots of earthquakes and volcanic eruptions happening all the time, and those events can absolutely trigger catastrophic tsunamis. Tonga is no exception. According to Dr. Annie Lau, a coastal geomorphologist who took part in the study, Tonga has a long history of tsunamis for exactly that reason. Take the tsunami that hit the country at the beginning of 2022, for example. That catastrophic event produced waves as high as 66 feet, with water pushing nearly 0.62 miles inland. It was so powerful that, tragically, it claimed the lives of at least 6 people, and it was actually triggered by a volcanic eruption. So yeah, tsunamis are pretty common in Tonga, thanks to all that magma and tectonic activity constantly happening beneath the surface. And a massive, powerful wave is likely what carried Makalahi up onto the cliff. According to the study, this event may have happened around 7,000 years ago. That's even older than the first human settlement in Tonga, which is believed to have occurred roughly 3,000 years ago. Interestingly, that estimated timeline lines up with evidence of a massive tsunami that hit New Zealand's North Island, around 1,300 miles southwest of Tonga. The researchers had a theory. Now all they had to do was run the numbers to see if it was actually possible. So they measured the boulder's size and weight, then used that data to model how big a wave would have to be to push such a massive rock that far inland. Their findings suggest the boulder may have originally sat near the edge of a cliff, but was shoved inland by a tsunami. The wave lasted about 90 seconds and reached up to 164 feet in height. That's almost as tall as Niagara Falls. Just to give you a perspective, that's significantly larger than the waves recorded during the Indian Ocean tsunami in 2004 or the Tohoku tsunami in 2011. Now, here's the thing. These tsunamis were triggered by earthquakes, and waves caused by earthquakes usually top out at just a few tens of feet. So, in Makalahi's case, it probably wasn't an earthquake that did the job. Instead, it's possible the wave came from a landslide tsunami. This theory suggests that the earthquake not only generated a tsunami that flooded the island, but it probably also triggered a massive landslide. When a huge chunk of material suddenly slides into the ocean or something shifts quickly underwater, it can create a landslide-triggered tsunami, and that landslide, in turn, may have produced a second tsunami. One powerful enough to carry Makalahi and drop it where it still sits today. Now, while science may have found a likely explanation for how the rock got to such a strange location, many locals will probably continue to pass down the traditional stories tied to rocks like this one. According to Polynesian mythology, coastal boulders like Makalahi were placed by the legendary hero Maui. In some legends, Maui used a giant boulder and a magical rope made from the hair of the deity Hina to anchor the sun and slow it down. Another story is known as the Maui Throwing Stones. It refers to a group of 8 coral limestone boulders located in the village of Havelukilu on Tonga-Tapu. The myth mentions that these massive stones were thrown to Havelukilu by Maui from the neighboring island of Eua. The story goes that Maui was annoyed by a rooster that woke him up every morning, so he picked up stones and hurled them at the bird. And that's how the rocks from Eua ended up in Tonga-Tapu. Now here's the interesting part. The term white chicken in Tongan also means foaming waves, so some believe this story may actually be a metaphor for a tsunami. Even though these myths don't mention Makalahi directly, they show how important rocks like these are to local people. Now, we can say that this archaeological evidence is not only important for culture, but also for science. The recent study gives us some fascinating theories about how the rock ended up so high up and so far inland. But researchers still need to find what's called a landslide scar to prove their point and fully solve the Tonga Cliff mystery. Follow-up research is crucial because it will help us to uncover what triggers these kinds of events and how often that might happen. And who knows? One day we might come across new cases of giant rocks moved by giant tsunamis, each one carrying its own story from the deep.
You're walking through a bustling town near the Bay of Naples. It looks full of life, energy, and healthy food. Look at these flatbreads that might have been ancient pizza, no less. The people of Pompeii are living their best lives. But all of that comes to a fiery halt in 79 CE. That's when Mount Vesuvius, that unassuming mountain looming over the city, decides it's time to make history. And the result is a tragic story that archaeologists are still piecing together 2,000 years later. Now, if you think Pompeii was some boring, dusty old place, well, think again. This was a lively, buzzing town. There were farmers bringing in fresh produce, merchants selling their goods, bakers cranking out bread and pizza-like flatbreads, and gladiators gearing up for fights in the amphitheater. The people of Pompeii loved decorating their homes with frescoes, mosaics, and statues. And food was a big deal. Pompeii was home to some of the earliest restaurants, called Thermopylae, where people could grab hot meals on the go. But let's get back to the fateful day when this beautiful, simple life ended. The saddest thing is that the people of Pompeii had warnings, they just didn't know it. Around 4 days before Vesuvius erupted, there had been minor tremors, but the locals were used to earthquakes. They had a massive one in 62 CE that destroyed lots of buildings, but they rebuilt the town and kept living there. No one thought, hey, maybe that giant mountain is the problem. So by the time 79 CE rolled around, Pompeii was back to normal, or so they thought. Now it's the morning of the eruption, just another regular day. People are working, shopping, and chilling in the baths. And then, out of nowhere, Vesuvius erupts. It was a catastrophic explosion that shot a plume of ash, gas, and rocks 20 miles into the sky. Pliny the Younger, a Roman writer who watched this disaster unfold from across the bay, wrote that it looked like a pine tree of fire and smoke rising into the heavens. Suddenly, it began raining with ash. First it was a drizzle, then it started coming in buckets. Gray, heavy rain that didn't let you breathe. Then hail began falling from the sky. But it wasn't hail. Those were pumice stones, light chunks of volcanic rock. They were smashing roofs and windows and piling up in the streets. That's when people started panicking. Some of them decided to escape, so they ran from the town. Others thought the walls of their homes would protect them. Well, they didn't. Soon things turned even worse. The ash had covered Pompeii's streets, and buildings were collapsing under its weight. But the real nightmare came early the next morning. Pyroclastic flows, a fatal avalanche of superheated gas, ash, and rock that was racing down the side of a volcano at more than 200 miles per hour. The heat alone, around 1,000 degrees Fahrenheit, instantly finished the life of anyone who ended up in the way of the flow. When the pyroclastic flows hit Pompeii, it was, unfortunately, game over for the town. Those who decided to stay in the city didn't stand a chance. The people were trapped so quickly that their bodies were left frozen in their last moments, some shielding their faces, others holding loved ones. In one bakery, archaeologists found the skeletons of 3 people who'd stayed behind. They thought the oven's stone walls would protect them, but those just weren't strong enough to resist the elements. When the eruption finished, Pompeii was covered with 20 feet of volcanic debris. What archaeologists eventually found when they uncovered the town was both mesmerizing and terrifying at the same time. Because Pompeii was buried so suddenly, Everything remained preserved: homes, streets, art, food, and even people. These days, scientists are rethinking what we know about the victims of the Pompeii disaster, thanks to new DNA evidence. Apparently, a lot of our assumptions about who these people were might be way off. A recent study by researchers from the US and Italy has shaken things up. They found that some of the victims, who they assumed were family members, weren't related at all. On top of that, the gender of some individuals was misidentified. The researchers believe that older interpretations were influenced by modern ideas about gender and relationships, which might have clouded the actual history. One of the study's co-authors from the University of Florence pointed out that conclusions based on limited evidence often reflect the biases of the time. Back then, researchers had to rely on the physical appearance of casts to make their guesses. Now, with DNA evidence, the story looks very different. Let's look at the case of the so-called family found in the House of the Golden Bracelet, which was discovered in 1974 on a Pompeii hillside. This group of 4 victims was named after an elaborate piece of jewelry was found on one of them. Based on the cast, one of the figures, who was holding a child, was assumed to be a mother. But the DNA results revealed this person was in fact a man. Even more surprising, none of the individuals were related, as scientists thought previously. Not surprising, given the extreme confusion and terror the people experienced as they desperately took shelter anywhere they could. Another interesting finding involves a pair of victims once thought to be sisters or a mother and daughter. DNA evidence now suggests that one of them was biologically male. Altogether, the researchers have analyzed the remains of 14 individuals for this study, and this is just a small portion of more than 1,000 victims of Mount Vesuvius's eruption that have been found so far. Archaeologists in Pompeii have also made one more discovery. Look at this figure. Initially, everyone believed that this man had been crushed by a massive boulder, a stone block that might have been part of a door frame during the eruption. His skull, with its mouth open as if in a final gasp, was found near his body. He was probably trying to escape all the chaos when it happened. But new evidence suggests that wasn't the case. His demise was likely the result of asphyxiation from a pyroclastic flow. For a long time, people thought Vesuvius erupted on August 24th. That's what some evidence seemed to suggest. But over the years, archaeologists started finding evidence that pointed to a later date. For example, they found graffiti dating back to late October and food remains, such as pomegranates. Such products wouldn't have been around in August yet. Plus, they found heating braziers in homes. Who would need extra heat in the summer of Italy? So, most experts agree that the eruption happened in late October. Now, it turns out that not everyone in Pompeii passed away. Scientists think that 15,000 people lived in the town, and only about 2,000 of them didn't survive the disaster. It means thousands of people managed to escape. But at the same time, their lives changed forever. They didn't have homes to come back to. Imagine fleeing your home with nothing but the clothes on your back, leaving behind everything you've ever known. Some survivors made it to nearby cities like Naples, but they had to start over from scratch. But recently, archaeologists made a pretty cool discovery: a fresco of a flatbread that might have been the ancient ancestor of pizza. Researchers found this painting in a house near a bakery. It shows a round bread sitting on a silver platter next to a goblet. They think people might have eaten this bread with fruits like pomegranates or dates, or maybe topped with spices or a kind of pesto. But the coolest part is that Pompeii is just 14 miles from Naples, which is the modern home of pizza. The director of Pompeii pointed out how this discovery connected a simple poor man's dish from ancient times to the modern pizza we all know and love. Today, Pompeii is one of the most famous archaeological sites in the world. Every year, new discoveries help us understand Roman life of those times even better. Hey, want to hear something shocking? In an ordinary house outlet that we use to charge the phone, the voltage is 110 volts. A high-voltage power line that provides electricity to dozens of buildings has a voltage of 100,000 volts. The energy of one lightning strike is more than 10 million volts. Woo! And the temperature of lightning is almost twice the temperature on the sun's surface. And this incredible charge is flying at a speed of just 2.5 times slower than the speed of light. Now imagine what happens to a person when lightning strikes them. Well, let me tell you, the discharge passes through the body in 1/100th of a second. Lightning can stop our hearts and disrupt the work of our entire nervous system. You may not even realize what has happened at first. Perhaps you will lose consciousness and your body will be in a state of shock. Every day, there are several million lightning strikes in the world. Fortunately, you have little chance of getting hit by one. The odds that lightning will strike you is about 15,300 to 1. About 20,000 people are struck by lightning every year. The chances that lightning will strike you twice are even smaller. And what are the odds that you'll be struck by lightning 7 times throughout your life? It seems impossible, but one person experienced it for himself. His name was Roy Sullivan. He was born in 1912 in Greene County, Virginia, in a big family with 7 children. Roy was an ordinary guy and was no different from his brothers and sisters. But for some reason, the natural element chose him. In 1936, he began working as a ranger at Shenandoah National Park. There, lightning struck him 7 times over 35 years. So, the first accident happened in April 1942. On that day, a strong thunderstorm began. Roy took refuge in a new fire tower where builders hadn't installed a lightning rod. Lightning struck the building several times. A massive fire started inside and Roy ran out. As soon as he was a few feet away from the shelter, lightning hit his toe and burned a hole in his shoe. The next time occurred 27 years later, in July 1969. Roy was working in the national park. He was driving a truck through hilly terrain when a storm started. Lightning struck him through the open car window. The charge burned his eyebrows and eyelashes and slightly touched his hair. Roy lost consciousness and the car continued to move. It stopped at the very edge of a cliff. 15 minutes later, Roy came to his senses. A year later, in July 1970, the third time occurred. The weather was fine, but in a matter of minutes, clouds became thicker and a thunderstorm began. Lightning struck a transformer near Roy. The man ran away as fast as possible, but nature got him again. Lightning hit his shoulder. 2 years later, in 1972, lightning struck Roy for the 4th time while he was working at the National Park Station. The charge set his hair on fire, and the man ran to the bathroom and used a wet towel to put out the flames on his burning head. From that moment, Roy began to suspect that some invisible evil force had been pursuing him. He started to carry a bottle of water with him to put out the fire in case of another hit. The 5th strike happened in the national park again. It occurred in 1973. Roy tripped over a rock and fell. At that moment, he noticed thunderclouds in the sky. Frightened, he ran to his truck, got inside, and stepped on the gas. Roy drove as far from that spot as possible. Then he stopped and got out of the car to see where the storm was. And at that moment, lightning struck again. It went through his left arm and left leg and set his shoe on fire. Roy quickly climbed back into the truck and extinguished the fire using his water bottle. In 1976, the 6th case occurred. Roy was walking along a trail in the park, just 1 mile away from the place where lightning struck him the last time. And then storm clouds appeared again. Lightning flashed and stung Roy in the palm. After the 6th strike, he began to suspect something was wrong with the park. After 40 years of working, Roy finally decided to quit. Finally. He hoped the lightning would stop chasing him, but he was wrong. By that time, the man had already become a celebrity. But such fame didn't let him enjoy life. People were afraid to be near him because they believed the lightning could hit them at any moment. Journalists gave Roy Sullivan the nicknames Spark Ranger and Human Lightning Conductor. Of course, the man disliked all of this and felt very lonely. But besides this problem, he also suffered from constant fears and the feeling of persecution. All the time, he was waiting for the lightning to strike again at any moment. Fortunately, he was married. His wife supported him and helped him in everything. After quitting his job, Roy decided to move with his wife to the small town of Dooms, Virginia. Wow, Dooms. Talk about foreshadowing. It was only a year without accidents. Then, on June 25, 1977, lightning struck Roy again. He went fishing at the local pond early in the morning. The catch was good, but the sky was overcast. Roy immediately felt there would be a strike. There was a smell of sulfur in the air, and the hairs on his arms stood on end. His whole body tensed. Lightning struck Roy in the head, passing through his chest and stomach. The man ran to his car to take cover. At that moment, a hungry bear came out of the forest. He approached Roy's bucket of fish to pick up all the trout the man had caught. Roy ran out of the vehicle with his hair on his head smoldering to chase the animal away. After the seventh lightning strike, he lost hearing in his left ear and realized he couldn't hide from the lightning anywhere. His wife was afraid to be with him outside during a thunderstorm. One day, she was hanging laundry in the backyard. Roy came out of the house to help her. A few minutes later, lightning struck his wife. Fortunately, she wasn't badly injured. After that, besides fear and social loneliness, he felt guilt. Of course, many doctors and scientists tried to help Roy, but no one managed to find the reason for this strange phenomenon. According to science, each time it was just a coincidence. Mathematics and physics were powerless here. With such answers from scientists, Roy believed that invisible forces were pursuing him or that fate was punishing him for something. Perhaps the answer lies in the man's past. The National Park Service and doctors documented all 7 times when he was struck by lightning. But there was another 8th time, which couldn't be confirmed. According to Roy, lightning struck him in his youth when he was helping his father mow wheat. The discharge hit the scythe blade. No one but the boy saw it. Perhaps at that moment, the lightning changed something in his body and made him more attractive for the next hits. Lightning always chooses the path of least resistance. And this is how lightning occurs. Rain, ice, and snow particles collide with one another inside a storm. This process increases the imbalance between clouds and the ground, negatively charging the lower layers of clouds. Things down there, like trees and the earth, get positively charged and create another imbalance. Nature tries to remedy this imbalance between the two opposite charges by passing an electric current through them. Perhaps nature felt some charge imbalance in Roy's body and tried to remedy it. But why did he get struck at an interval of 1 to 2 years? Besides, more than 20 years passed between the first and second hit. Scientists still can't explain what happened to him. Maybe Roy was just an attractive guy. As you can probably predict, Roy Sullivan was listed in the Guinness Book of Records as the person struck by lightning most often in the world. Winds howled, snow swirled everywhere, and visibility dropped to almost zero. 17 climbers were trapped on top of Mount Everest, running out of oxygen. Did they have a chance to survive? And why would that day go down in history as the 1996 Mount Everest disaster? At the end of March that year, a team of 18 people led to the top by Rob Hall came together in Kathmandu, Nepal. The very next day, they began their 9-day-long hike along the Himalayan paths. By April 9th, they finally reached base camp, which is the starting point for climbing Mount Everest. The journey wasn't easy, and many team members got sick on the way from the altitude. At the same time, another climber, Scott Fisher, was leading his team of 19 people to base camp. When both teams arrived there, they started exercising and learned how to breathe where there wouldn't be much oxygen. On Rob's team, one climber got frostbite on some of his toes, and his throat froze, making it hard for him to talk. On Scott's team, one man had trouble breathing even while at base camp, so he had to use bottled oxygen there. Another severe problem happened with one of Scott's Sherpas. Those guys work as guides and porters for climbers in the Himalayas. They can carry loads up to 2 times as heavy as their own weight up and down the mountain. An average, physically fit adult man can carry a backpack loaded with a quarter of their body weight without a problem. So those Sherpas are really like real-life X-Men. They've also developed the superpower to survive low-pressure, low-oxygen conditions at high altitudes. Scientists suggest it's because they have lower oxygen concentrations in their blood and more oxygen flows to their muscles. It could also be their genes. In either case, one of Scott's superhuman Sherpas got sick and could barely breathe because of the thin air. He was forced to return to the hospital, but passed away several weeks later. Sadly, it wouldn't be the only demise on that tragic ascent. The teams pressed on and departed base camp on May 6th and reached Camp 2 on the same day. 3 days later, they made their way to Camp 4, the final camp before the summit. The plan was to climb to the summit and return to Camp 4 within 18 hours. Staying too long at such high altitudes, especially without extra oxygen, could be very dangerous. Meanwhile, one climber from another expedition that was also on its way to the top stepped out of his tent without properly attaching the sharp spikes on his boots. Without them, he slipped and fell into a deep crack in the ice on a steep part of the mountain. But after he was rescued, he still decided to climb down the mountain the next day and didn't survive. At that point, the teams were in the zone where there isn't enough oxygen in the air, so it's hard for the human body to survive. Some climbers from the groups met another team who were heading back down the mountain. They told them it was too dangerous to push on because of bad weather, but no one listened to the warning. At midnight on May 10th, climbers from different groups started their journey to the top. Each of them carried 2 extra oxygen tanks, but they knew the oxygen would run out by 5 p.m., so they had to climb up and get back down quickly. The Sherpas who helped set up safety ropes were delayed, so the climbers had to wait for an hour on the steep slopes. Some climbers were less experienced, which slowed the entire group down. The leader of the first group, Rob Hall, had told everyone to turn back by 1 or 2 p.m., whether they made it to the summit or not. Around 1 p.m., the first group of climbers reached the top of Mount Everest. Many climbers didn't turn around at the planned 2 p.m. deadline. Scott Fisher let his team keep going until after 3 p.m. Rob Hall and one of his climbers, Doug Hansen, didn't make it to the top until 4 p.m., far too late to start heading back safely. By then, the weather was getting worse. By 3:30 p.m., a storm began rolling in, and by 6 p.m., it had become a full blizzard. Some climbers got back to camp safely, but by 10 p.m., half of the group was still stuck in the storm. One group was stranded at 27,000 feet, just 200 feet from Camp 4. The blizzard made it impossible to see, so they decided to huddle together and wait for the storm to pass. Rob Hall and Doug Hansen were stuck near a steep, icy section called Hillary Step. Hansen collapsed, and Hall stayed with him. Hansen's body was never found. Later, Sherpas found the bodies of other climbers at different altitudes on the mountain. The disaster took 8 lives in total and injured others. It was the highest number of fatalities within 24 hours on Mount Everest. 5 years after that, the mighty Everest did everything to stop Marco Sevriti from being the first person to snowboard all the way down its summit. The route he chose for the descent didn't have enough snow, so the French mountaineer and snowboarder had to choose another one. After just 660 feet of the journey, a fastening strap on his snowboard broke because of the cold. A Sherpa helped him to repair it, and he finished the descent to 21,000 feet in 2 hours. The next year, Marco came back to repeat his success on a different slope of Everest. It was August, so it was kinda late in the season, but it didn't stop him. Marco reached the summit with 3 Sherpas on the 8th of September. He was really tired by then, and the weather was changing, so his guides told him not to go. But he didn't listen. The Sherpas lost sight of him several times. About 4,300 feet below Camp 3, the Sherpas saw a distant figure of a man who stood up and then disappeared down the mountain. No one ever found either Safridi or snowboard tracks leading to his last refuge. But we might still hear about Marco, as it sometimes takes about 100 years to find traces of someone who was lost on Everest. On June 8, 1924, Andrew Sandy Irvine and George Mallory set out to do something no one had ever done before – reach the top of Mount Everest. But something went wrong, and the two men vanished in the icy heights. No one knew if they had made it to the summit before disappearing. If they had succeeded, they would have beaten the first ascent record that was set only 29 years later. In 1999, climbers found Mallory's body on the mountain. But then, for some reason, the body mysteriously disappeared. Climbers couldn't locate it with drones or cameras, even though they had the exact coordinates of the spot. It looks like someone moved it, but no one knows why. Then one day in September 2024, a team working on a National Geographic documentary spotted something unusual, a boot sticking out of the ice on a glacier far below the steep north face of Everest. The leather looked old and cracked, and the steel hobnails on the sole were from a time long ago. Inside the boot, they found a sock with a red label stitched inside. It said A.C. Irvine, confirming that these were Sandy Irvine's remains. A few days earlier, while hiking down the central Rongbuk Glacier, the team had discovered an old oxygen bottle from 1933. That bottle wasn't connected to Mallory and Irvine's climb, but it helped the team figure out where objects and bodies might fall if someone slipped down the mountain. Irvine had carried a small Kodak camera during the climb, and many believe the photos inside it might hold the answer to the biggest question: had they reached the summit before they passed away? Members of Irvine's family have offered DNA samples to confirm his identity.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Utarunku probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington state in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it.
July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, it lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore. Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or a big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, it had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling. The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored, sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected.
Marriage is not only about happiness, mutual support, love, and friendship. Marriage is also about trials, crises, and storms. And this Swedish couple survived several storms during their honeymoon. Literally. Not screams, insults, and drama, but real hurricanes, fires, earthquakes, and other natural disasters. This is a really cinematic love story. Newlyweds against nature. Meet Erica and Stefan. They met in Stockholm while working on a joint project, parted but started chatting with each other on social networks. Their long-distance communication lasted for several years before Stefan decided to ask the woman out on a date. And it's worth paying tribute. It wasn't a typical date in a restaurant or in a park. Stefan suggested that Erica fly with him to go diving in Egypt. They realized that they both loved to travel and finally fell in love with each other. After a fabulous wedding and the birth of a beautiful daughter, the couple decided to go on a 4-month honeymoon. The tour was impressive. From Sweden to Indonesia, then to Australia, New Zealand, Japan, and China. They didn't expect that the trip would turn out to be a real adventure where safety was not guaranteed. At first, they got stuck at Munich airport. All flights were delayed because of a severe thunderstorm. In Bali, Indonesia, they went to a high mountain with their little daughter. A strong wind began to blow at the top. It tore off the roof of the tourist bus where our heroes were sitting. Fortunately, no one was injured, and there were no other problems. But at that moment, it was just a teaser of the coming disasters. The couple arrived in Australia, where a wildfire first started near the city of Perth. Stefan and Erica didn't want to cough up thick smoke, so they quickly left for the city of Cairns. It was during that period when a ferocious cyclone began there. The storm was so strong that the Australian Red Cross Service provided shelter for 2,500 people in the mall. And there, another problem began. Imagine 2,500 people in a big, hot room without electricity while a hurricane is raging around. Oh, and there were only 5 toilets in the entire building. How nervous do you think people were? Eric and Stefan recall that some guys started fighting because of stress. The tension was getting stronger, but fortunately, the mall guards kept the situation under control. Wildfires, hurricanes, it seems that something is missing. Oh yes, what about an earthquake? The couple faced 2 earthquakes during their honeymoon, one of which happened in Japan in 2011. They went through all this together with their little daughter. Just imagine how their daughter was amazed by all these adventures. Such a trip strengthened their marriage. Of course, after natural disasters, any domestic quarrel would seem like a mere trifle. Erica admitted that in crisis situations, Stefan fully justified her trust and behaved as she had hoped. Oh, how sweet. What if we create tours for married couples who are planning to divorce? Survive the storm, fire, earthquake, and flood together, and then think again whether you should leave each other. Imagine that you've gone through several natural disasters in your entire life. Now the question is, are you lucky because you've survived, or are you an unlucky person because you've run into such troubles? It depends on how you feel about it. For example, there's a woman, Dana Weiland, who lives in California. She has survived several disasters throughout her life and continues to smile. And more recently, she's faced another disaster, wildfires in her home state. But let's take it in order. In 2005, Dana Weiland lived in New Orleans, and if anyone doesn't know, that year, Hurricane Katrina destroyed many houses in this and other cities. Dana's house was no exception. According to her, the lower floor of the house was completely flooded with water. Of course, she had to give up everything and evacuate. Dana and her family drove to Texas to a friend's place for about 20 hours. 1 month later, Hurricane Rita arrived there, and Dana and her family evacuated again. It looked as if nature was following her around, but our heroine was not one of the timid ones. Several years later, she faced another disaster, Snowmageddon. This was when a huge amount of wet, cold snow flooded cities and roads. Strong wind, blizzard, and endless snowfall. All traffic stopped. The lights turned off. The streets were empty. Dana sat for 11 days without electricity during this snow apocalypse. And after all these disasters, she got the exact opposite of snow. Wildfires in her hometown of Lake Arrowhead in San Bernardino County. Let's hope that this time, everything will be fine with her again, and she will meet any adversity with a smile on her face. Have you heard that lightning doesn't strike twice in the same place? Can it hit the same person twice? What if it strikes the same guy 7 times in a few hours? This is not a movie plot in a tragicomedy genre. This is the real story of Roy Sullivan, a man who got into the Guinness Book of Records for the number of lightning strikes survived. There are more than 8 million lightning strikes on Earth every day, which is about 100 strikes per second. But even so, the probability of getting struck is extremely low, 1 chance in 10 million. For Roy Sullivan, these chances were too high. For his strange record, people nicknamed him the Human Lightning Rod. For the first time, lightning struck him in 1942, when Roy was on a watchtower that didn't have a lightning rod. A bright flash of light and a powerful current discharge scarred the man, but didn't cause crucial damage to health. The next accident occurred in 1969, when lightning struck a tree near the road. The lightning passed through the tree to a car. Guess who was driving this vehicle? Roy lost control and almost drove off a cliff. Fortunately, he stayed alive again. Okay, the first time he was on the tower during a thunderstorm. The second time was on the road next to a tree, and as we know, lightning often strikes trees. This meant Roy was in a potential risk area every time. But the third time happened in his front yard. Lightning struck the transformer and caught his shoulder. The fourth time happened in 1972. Lightning struck Roy while he was working. From that moment on, the man began to suspect that this natural phenomenon was somehow attracted to his body. Maybe it was a curse, or maybe everything could be explained from a scientific point of view. A year later, lightning struck him for the 5th time. A thunderstorm started that day. Roy decided not to try his luck again and hid in his truck. And so, when the storm calmed down, Sullivan got out of the car and bam! Another lightning strike. There were 2 times left before the record. They occurred in 1976 and in 1977. Roy's bad luck spread to his wife. One day, lightning struck her too. It didn't hurt her, but scared a lot. So far, no one has broken Ray's record, but obviously people haven't tried to do that. Okay, lightning, fires, snowstorms, hurricanes, and earthquakes. But how about tsunamis? Unfortunately, this is one of the most terrible and devastating disasters on the planet. If you survived it, you're definitely lucky. Zarul Fuadi from Indonesia survived these devastating water disasters twice. The first occurred in Indonesia in 2004. And the second happened a few years later during an earthquake in Japan. During the second time, Zarul was in the building on the 3rd floor and felt a jolt. He was shocked and immediately remembered the tsunami he had experienced before. The tsunami hit the city, but our hero and his family survived. After this double trouble, he decided to move to his homeland, Indonesia. Despite the terrible events, Zarul looks at what happened calmly. Any catastrophe can happen to any person at any moment, but it doesn't mean you should live in fear forever. So, he focused on the bright side of life. When lightning flashes across the sky, it releases somewhere around 300 million volts, or the equivalent to power 25 million car batteries. Some say you're more likely to be zapped by lightning in your lifetime than to win the lottery. And statistics seem to prove this urban myth, as each year around 28 US locals do get electrically charged from the sky. The world's infrastructure can be affected by lightning too. That's because it generally seeks out the tallest structure around. But in certain conditions, it can also strike an open field. So scientists came together and invented a laser lightning rod that might help. This unique invention might make lightning strikes a bit more manageable, since it can guard a much larger area than the traditional one, and it's flexible. Classic lightning rods work like magnets for that powerful electrical charge. There are these tall metal devices placed on top of buildings. When a storm approaches, the rod provides an easy path for lightning to follow, preventing it from hitting other parts of the structure. The rod is also connected to the ground with a conductor, like a wire, helping the electrical charge to safely make its way into the earth. This process protects the building and the humans in it by directing the electrical energy away. We've been using lightning rods for the last 300 years, courtesy of Benjamin Franklin. But they're not damage-proof. When it comes to safeguarding vast spaces like airports, they can't manage. That's because they can only cover an area proportional to their height. Here's where this new, improved lightning rod can help. When the laser zaps the sky, it leaves behind a trail of superheated air called plasma. The same way a sculptor carves out traces in clay, the laser creates channels in the air. These channels then become the lightning's new favorite route, guiding it down to the ground. This new method was tested in the Swiss Alps back in 2021, and the results were promising. These lasers do have their own disadvantages. They aren't always available and need a heads up. That's because they have to be activated before a bolt hits. If you're a second too late, tough luck. Also, once the laser stops, the air loses its conductivity pretty quickly. This means the laser rod might not have enough power to guide the lightning safely. A potential solution might be monitoring the electric fields around a certain area, predicting where lightning might strike. Yet, these new rods still need more testing and lots of funds. The European Space Agency found another way to make lasers useful: to turn moon dust into roads. It would make our future lunar exploration missions much easier if a laser beam could do the hard jobs, allowing astronauts to drive around the moon. This discovery might also help with another tricky issue: moon dust clinging to everything in sight. Roads on the moon might seem too much of a hustle for now, since we haven't been to our satellite since 1972. But when future space explorers will touch down again, they don't just plan to walk small distances. It'll be nice to have them driving around so they can explore larger areas. Problem is, that pesky moon dust is very fine, abrasive, and sticky. Back during the Apollo missions, it clogged up equipment, eroded spacesuits, and even caused a lunar rover to overheat. That's why scientists want to zap simulated moon dirt with a laser. This laser-powered project used a 12-kilowatt laser to melt simulated moon dirt into a solid, glassy surface, perfect for moon roads. The plan isn't to send a huge laser on the moon. This device they're testing here on Earth is like a stand-in for the sun, mimicking what lunar sunlight could do. The idea is to eventually concentrate sunlight using a big lens on the moon's surface. Some experiments have been done so far with different laser sizes, finding that a bigger beam made the whole process go smoother. Instead of dealing with tiny molten balls, they got a stable layer of molten moon dirt that's easier to work with. What they got was a glassy, somewhat brittle material that can handle downward forces. And even if it cracks, it's fixable. The laser beam was used to make triangle-shaped road parts that fit together like puzzle pieces, forming solid surfaces across lunar soil. If this goes as planned, we'll have moon roads made of interlocked triangles. This unique type of moon pavement could be the solution for landing pads too. Lasers can help piece together information on long-lost civilizations too. Discovering Maya cities has always been difficult for researchers exploring Mexico's Yucatan Peninsula. For years, experts believed no early civilization could have thrived in that harsh environment. But advancements like light mapping technology and laser scans are showing us this might not be true. LiDAR technology can lend a helping hand for archaeologists, especially in areas that are hard to physically reach. That's because it's like we're equipping computers with a pair of eyes. The whole thing works as a flashlight, sending out small light beams in the form of a pulsated laser. These beams bounce off objects like trees and buildings and come back to the flashlight. LiDAR measures how long it takes for the light to return, creating a map of the surroundings. When a self-driving car or robot wants to know where it is, it uses LiDAR to send out these light beams. By figuring out how long they take to come back and where they hit, the car or robot can understand what's around it, making it safer for them to move around through the fog or at nighttime without bumping into things. With this technology, a team uncovered the massive Maya city of Acomtun. LiDAR technology helped researchers to map the jungle floor, revealing hidden structures. Yet someone still needed to verify these findings on foot. The journey to Acomtun wasn't extremely challenging. The region, quite far from the nearest airport, is mostly unexplored, accessible only through old hunting and logging routes. The dense terrain made the trek challenging, taking the team up to 2 weeks to cover just 30 miles. But the effort paid off, revealing monumental structures like a large acropolis and intriguing shapes hinting at a marketplace or cultural center. LiDAR is also used in rovers we'll need to explore other planets. This will allow the robots we send up there to navigate their surroundings without direct human indications. It's also helped us better understand the best location to place solar panels, making it cheaper and faster for us to meet our energy needs. We might also be able to use lasers to predict how a volcano is gonna act. These structures are loaded with magma, the molten rock sneaking upwards from the Earth's insides. When a volcano blows its top, a chemical reaction happens, transforming magma into what we call lava. The specialists behind this new use of lasers think of magma as the computer code of volcanoes. It reveals information on how a volcano might pop up. That's because not all eruptions bring lava, and even if they do, there are different lava types, depending on how runny it is. Magma is like a mix of liquid, gas, and crystals that are shaken up inside the volcano. There are many elements at play before a volcanic eruption, so it's hard to study and understand that complex chemistry. To organize things around a bit, scientists hit the cooled magma, the rock matrix, with a laser. Just like the ones you might have encountered if you've ever had eye surgery. It makes the chemical components easier to study. This latest laser eye method was used on samples from a 2021 eruption, which lasted 85 days. It covered over 4 square miles, spewing loads of lava that wrecked over 1,000 homes and displaced over 7,000 people. To prevent such events from happening again, scientists need more data. It's true, earthquakes and ground shifts help specialists predict what a volcano might do, but knowing a bit more about its chemistry can help a bit more. The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems, those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption.
The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors.
Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or a pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
Not an earthquake, but a mega-earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega-earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega-earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega-earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega-earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe. a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega earthquake and a tsunami is about 80%. Over the past 1,400 years, mega earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. Hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation. But the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing.
Finally, the thunderstorm has passed, and it's all sunny again. No clouds in sight, no need to spend the day indoors, after all. Suddenly, a lightning bolt slams into a tree just 100 feet away. Whoa, what just happened? Can storms be invisible? Is Thor fighting someone near your home? No. This is an exceedingly rare but very real weather phenomenon that scientists call bolts from the blue. Sounds unbelievable and a bit scary? Well, today I'm talking about nature's weirdest and deadliest jump scares. But first, back to science class for a second. What causes thunderstorms and lightning in the first place? On a sunny day, the ground gets toasty and the air near it heats up. As this warm, moist air rises, it enters colder layers of the atmosphere. The moisture condenses into tiny water droplets, and when they gather, well done, now we have a big puffy cloud. But sometimes the rising air just won't stop. It keeps going until you get one of those towering thunderclouds called cumulonimbus. Inside them, it's chaos. Raindrops, ice chunks, and water are tossed around like they're in a big sky blender. When those little bits bump into each other, they trade tiny electrical charges. All that bumping and crashing swaps those charges until the whole cloud turns into a charged-up battery. Positive up top, negative down below, ground buzzing underneath. Then, boom! The imbalance breaks and a lightning bolt tears through the sky. In a split second, it superheats the air to around 50,000 degrees Fahrenheit, which is hotter than the surface of the sun. The air explodes outward so fast that it creates a shock wave, and that's the starting sound of thunder that wakes up your dog. Normally, all this happens right under the storm. Since it can look scary, you know it's time to run inside. However, lightning doesn't always like these rules, and that's when we get the so-called bolts from the blue. Under normal lightning, these launch from the very top of a storm, travel sideways through the upper atmosphere, and then dive down, sometimes up to 30 miles away. They can be extremely dangerous. That's why experts recommend the 30-30 rule. If lightning and thunder are less than 30 seconds apart, get inside and wait 30 minutes after the last rumble. This all sounds frightening, but remember, the odds of being struck by lightning are already incredibly small. And when it comes to a bolt from the blue, it's so rare that scientists don't even have enough data to calculate the odds. Now, most lightning stays within 10 miles of the storm where it originated. When it travels more than 60 miles, we call that a mega flash. In 2017, scientists recorded one spanning 510 miles from Texas to near Kansas City, twice as wide as California. Now, let's talk about another weather-related surprise that comes out of nowhere. They are called dry microbursts, bursts of air that can cause chaos. Here's how it works. High up in the thunderstorm, raindrops begin to fall. But as they drop through a layer of very dry air, something strange happens. They evaporate before reaching the ground, and when that happens, it cools the surrounding air really fast. Now, that cold air is suddenly way heavier than the air below it, so it drops like a rock, picking up speed as it falls. These wind blasts can reach speeds of over 100 miles an hour, hit an area less than 3 miles wide, and last only 5 to 15 minutes. But in that time, they can flatten trees and hurl dust like a low-flying sandstorm. That hurricane-force wind blasts straight downward from the clouds, then slams into the ground and spreads out in all directions like a mini shockwave, like the ground was hit by an invisible air meteor. Such microbursts are especially dangerous for airplanes during takeoff and landing. A sudden downward burst of air can tilt, destabilize, or even flip a plane if it's low enough. First, the outflow gives it a tailwind, making the plane lift. But just seconds later, the wind shifts to a powerful headwind, cutting lift and forcing the plane down dangerously fast. In other words, it gets pushed forward, then slammed down, then slowed down too much, all while it's trying to land. The pilot only has a few seconds to react, and there's not much room under the plane to recover. It's like the sky's just changing its mind 3 times in a row, and the plane gets caught in the middle. Microbursts were once such a mystery that pilots had almost no defense. But after several major accidents in the 1980s, studying them became a top priority in meteorology. Today, airports use Doppler radar and wind shear alerts to catch them before they occur. For the next weather trap, imagine yourself walking through a peaceful valley at sunset. The air is still, the sky is clear, everything feels calm, almost too calm. Then, suddenly, the temperature drops in just a few minutes. You actually feel the cold sliding down the hills like fog, creeping along the ground and pulling around your ankles like an invisible air creature with cold hands. Your breath becomes visible, your hands start to burn from the chill, and you just stand there confused. This phenomenon is called the cold air pool. Basically, when the sun goes down, the ground cools fast. The air right above it cools too. Cold air is heavier than warm air, so it slides downhill like invisible water. If you're in a valley, basin, or any kind of bowl-shaped area, that cold air settles at the bottom and just sits there because there's no wind to push it away. If the skies are clear, the air keeps getting colder and colder overnight. And since the cold air can't escape the valley, the temperature can plummet to record lows, even if places just a few miles away have perfectly normal temperatures. This isn't just chilly, it can be life-threatening. In winter, this effect is stronger and more dangerous because from the beginning, the air is already cold, so we have extreme lows. In a place called Park Sinks, Utah, temperatures have dropped as low as minus 69 degrees. That's colder than some parts of Antarctica. And it happens without warning. One moment it's sweater weather, and a few minutes later it's, man, I hope I still have fingers. If cold air pools are like nature's freezer, then strudels are its drain holes. They form in spring when snowmelt floods river deltas over sea ice. The incoming fresh water floods the surface, finds cracks or weak spots, and drains downward in narrow jets. Think of vertical whirlpools cutting through the ice. This drainage is driven not by salty water trickling up, but by the pressure of the flooded layer pressing through cracks and seal breathing holes. From above, they spin into perfect spirals, almost too pretty for something that can rip through sea ice. These jets can dig into the seafloor, creating holes that can be several feet deep. This is risky if you're on the ice and could be a problem for any underwater pipelines nearby. Terrifying if you're too close, but mesmerizing if you could see them from above. Now these weather quirks are interesting, but there are more. Ever heard of ball lightning? A glowing orb floating across your room, humming, and then pop! No one really knows how it works, but it's been spotted on planes and in kitchens. Then there are sprites and blue jets, bolts of lightning that shoot upward from storms into the stratosphere like sky tentacles or neon jellyfish. Gorgeous, spooky, and visible only from above. Not to forget Haboob, a massive wall of dust that rolls across the desert like it's auditioning for a disaster movie. One minute it's sunny, The next it's midnight at noon, with grit on your teeth and sand in your eyebrows. But these are for some other time. The bottom line is, nature is beautiful and unpredictable. Sometimes it launches a lightning bolt from a sunny sky, or turns calm weather into a down-blasting wind hammer. So, next time you complain about the bad weather, remember, at least it's not trying to ambush you with unexpected freezing or bolts of lightning without clouds and rain in sight. Good luck!
It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these megaquakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater, arms in, they spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting.
So listen up. One day our sun will cool down and turn into a white dwarf. But this is not the worst thing for Earth. Before the star cools down, it will grow to an incredible size and arrange Ragnarok for us. Now, in case you don't know, Ragnarok is the fire apocalypse from Nordic mythology. So our star will burn down absolutely everything on our planet. But hey, don't worry, there's good news. This one day will come in 5 to 7 billion years. The bad news, though, is that almost all complex life on Earth will become extinct much sooner, maybe in 250 million years. But there's a small chance that our planet will be ruled by octopuses. Yeah, I know, this is too much news for the first few seconds. So let me break it all down for you, one thing at a time. We all hear about people destroying nature and polluting our planet. This is all true, but even without our intervention, the vast majority of living creatures on the planet will disappear, including ourselves. The reason is natural disasters and weather change. It sounds terrible, but it's not new to Earth. Scientists have found out that there have already been 5 mass extinctions. The last one happened about 65 million years ago, when dinosaurs disappeared. But life won anyway and took on many different forms. The 6th apocalypse may occur within the next 250 million years. Conditions on Earth at this time will be unsuitable for mammals because the level of carbon dioxide will be twice as high. This will happen because the sun will release 2.5% more radiation and it'll get too hot on Earth. The temperature in most parts of the planet will reach between 104 to 158 degrees Fahrenheit, and the entire land will turn into one supercontinent. In regions with high humidity, the temperature will be even higher, and of course, under such conditions, it will be difficult for people to walk in the park and play frisbee with dogs. No one will play with anyone at all. Let's hope we'll have colonized other planets by this time. Increasing solar fluxes will lead to a sharp loss of oxygen in the atmosphere. This means that in about 1 billion years, our Earth will look like the lifeless place it was about 2.5 billion years ago. That is, before the Great Oxidation Event. At that time, the air was filled with methane, carbon dioxide, and other gases, and the planet was inhabited by the simplest bacteria. Some of them learned how to make oxygen from sunlight and carbon dioxide. Throughout billions of years, they made so much oxygen that it became enough for the birth of new, more complex forms of life. And it seems we will return to these prehistoric times. Now, humans can't exist in such conditions, but some complex life forms hiding in the dark depths of the ocean might be able to adapt to the changed atmosphere and become the masters of Earth. These complex life forms are octopuses. There are many species of these animals. Some live in coastal areas, while others dwell in the deep waters of seas and oceans. And some species may be able to survive and create a new civilization. But why octopuses? Because they're some of the most intelligent creatures on Earth, and probably the most intelligent creatures among all the inhabitants of the dark depths. Octopuses can use surrounding objects as tools. For example, they can wear a coconut shell for protection or shelter. In laboratories, they've used various objects to complete mazes. These animals often escape from their water tanks to visit octopuses in nearby tanks. Yes, they have high intelligence, but not in the human sense. Their intelligence is more like a computer. You see, octopuses have neurons not only inside their brains, but also inside their 8 tentacles and large eyes. It's like a big data center, and their limbs sense the environment in exceptional detail, as if they were the brain. Not only their intelligence, but also their physiological properties might help the octopus survive if the apocalypse strikes. Its body has no skeleton. It can squeeze through any hole, slip past any obstacle, and their 8 highly developed limbs allow them to intelligently interact with their surroundings. Crows can bend pieces of wire with their beaks. They can throw stones into the water to raise the water level and get food. But they only have one beak. An octopus with its tentacles has at least 8 times more possibilities. They don't have spines, so they'll most likely build a civilization not on land but underwater, where it's much more convenient to move with such a body. To build a civilization, they'll need to find cheap energy. For example, hydrothermal underwater springs or tides in coastal areas. This will be a difficult task, but it won't be the most challenging thing for creating cities. It's very difficult for them to maintain social connections. By their nature, they are loners, who usually form groups of several individuals. But this is not enough to carry out large-scale construction of underwater urban areas. Parents pass on culture, history, upbringing, and moral guidelines to their children. They spend a lot of time and effort on education. Octopuses don't do this at all. The female octopus passes away shortly after laying eggs. The male octopus has only one mating relationship in its entire life and passes away shortly after the female is fertilized. So, in a sense, octopus cubs are born orphans. It's not surprising that it's difficult for them to build social connections. Over the past 50 to 100 million years, octopuses have not developed a collective feeling, and it's difficult to imagine that it will suddenly appear in the future. Perhaps something will encourage them. Who knows? Some scientists who study octopuses have noticed that over the past 10 years, some octopus species have shown certain social skills. Some live in groups of 10 or more individuals. If humanity doesn't ruin the lives of these animals by fishing and dumping garbage into the ocean, then they have a good chance of succeeding in conquering the planet. But if they fail, then the next candidates might be nematodes, those little white worms. Well, let's hope octopuses win. They seem cuter. They also may achieve a technological breakthrough much faster than we think, because when you have 8 arms, you work much better. Imagine these octopuses leaving Earth and flying to another galaxy, where they meet us humans. Do you think we could become friends? So let's say octopuses become a highly developed civilization that builds cities in the oceans. But they, just like humans, will have to think about colonizing other planets because of the upcoming Ragnarok. The sun keeps heating up and getting bigger, don't forget. Our star is currently in the most stable phase of its life. It has been in this phase for the last 4.5 billion years. But after another 5 billion years or so, the hydrogen in its core will start running out, and then the fun will begin. As hydrogen fusion slows, the core begins to contract. As the core gets smaller, it heats up until it can kick off another round of nuclear reactions, fusing helium into heavier elements such as carbon, nitrogen, and oxygen. Eventually, the sun will turn red and be so gigantic that it will swallow up Mercury, Venus, and possibly Earth. So, it may be Ragnarok not only for our planet, but for the whole solar system. No matter how tough octopuses are, they won't survive such a disaster. Earth is likely to burn down completely. Maybe it'll look like the moon, or it'll completely disappear. What will happen to the sun next? Its energy will run out sooner or later. Then it will shrink to the size of Earth and turn into a white dwarf. When a star goes out, it ejects a huge amount of gas and dust. Only the cooling core remains. All those outer layers will be floating in space, forming a beautiful nebula, and our solar system will become unrecognizable. Well, in some ways, it can sound pretty sad and scary, but hey, look at the bright side. Yeah, pun intended. It's going to happen in 5 to 7 billion years, so relax. Humanity has been living on Earth for about 40,000 years. If we compress the entire history of our planet into one 24-hour day, then the history of people will be equal to 1 second. If we achieve such a development in 40,000 years, what'll happen in 100,000 years, in 1,000,000 years, in 1,000,000,000 years? It's hard to predict. So how about going to the park and enjoying the sun at its best? Bring some sunscreen.
About 2 billion years ago, a massive asteroid crashed into Earth, leaving behind total destruction and what we now call the Vredefort crater in South Africa. And get this, This space invader might have been way bigger than scientists originally thought, possibly twice the size of the asteroid that wiped out the dinosaurs. Nowadays, the Vredefort crater is about 99 miles across, which makes it the biggest visible crater on Earth. But technically, it's still smaller than the Chicxulub crater in Mexico. The latter is about 112 miles, and it was left by the infamous dinosaur distractor 66 million years ago. But the thing is, craters don't stay the same forever. Over time, erosion wears them down. That's why they start looking smaller than they used to. And scientists think that when the Vredefort crater first formed, it could actually reach 174 miles across. That means it was the biggest impact site Earth has ever seen, even though it looks smaller today. Just imagine how insane that impact must have been. A space rock that would have sent shockwaves ripping across the planet, triggered enormous wildfires, and completely changed the climate. The asteroid likely hit Earth at a very, very high speed. But since this catastrophe happened billions of years ago, way before dinosaurs or even complex life saw the light of day, it didn't wipe anything out like the Chicxulub asteroid did. At the same time, recently, researchers have realized that the asteroid might have been even bigger than they thought previously, up to 15.5 miles wide. As for the speed at which it slammed into Earth, it could reach a staggering 56,000 miles per hour. Now, figuring out how big Vredefort originally was, that's been a bit of a headache. The main issue is that it's super old, and we're talking about 2 billion years old. No wonder that over that much time, erosion has kind of worn it down, so it's hard to tell just how huge it once was. But it's not just erosion causing the problem. Over the years, new layers of rock have built up over parts of the crater, and they've covered up most of the original structure. That's why now only little pieces of the raised rim are left, and this makes it even harder to get a clear idea of how big it was. So, scientists started looking at the minerals around the crater, like quartz and zircon. They discovered that those were all messed up by the asteroid's impact. They had tiny fractures caused by the blast. Researchers studied those damaged crystals and managed to figure out how far the explosion actually spread. Equipped by this new knowledge, scientists now believe that their latest estimates of the size of the asteroid are the most accurate ones. The reason why we haven't heard much about this disastrous impact is that, unlike the Chicxulub asteroid, which wiped out the dinosaurs and reshaped life on Earth, the Vredefort asteroid hit at a time when Earth was a very different place. There were no trees, no animals, just single-celled life in the oceans. That means no mass extinction, no burning forests, no fossilized evidence of chaos. But scientists think it still had a massive impact on the planet. It might have changed the climate even more dramatically than the asteroid that ended dinosaurs. But since we don't have much direct evidence of the disaster, studying what's left of the Vredefort crater is one of the only ways to understand just how powerful this impact was. Even though it happened billions of years ago, learning about this impact can help us understand the history of our planet, and maybe even prepare for future asteroid threats. After all, they could be similar to what happened in Siberia at the beginning of the 20th century, pretty recently. It was a warm morning, June 30th, 1908, when the sky suddenly lit up with a blinding flash. What followed was an explosion so powerful that it remained a mystery for decades. Known as the Tunguska event, it was one of the most baffling disasters in history. Scientists suspected an asteroid impact, similar to the one that wiped out the dinosaurs. But there was one eerie problem. No crater was ever found. The explosion struck deep in the remote forests of Siberia, near the Podkamennaya Tunguska River. The blast was beyond anything seen before, flattening around 80 million trees across an area of 830 square miles. The sheer force of the event was mind-boggling. It was strong enough to devastate the landscape, scorch the ground, and wipe out countless animals. According to witnesses, there was an eerie glow in the sky, which was followed by a streaking fireball with an intense bluish light. It was brighter than the sun. moments later, there was a deafening blast. The shockwave was so powerful that it shattered windows hundreds of miles away, and people were knocked off their feet. Yet, despite the destruction, the source of the explosion left no obvious trace. Later, scientists finally started to understand what had occurred on that day. Imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up all of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. And since the explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface. Another wild story happened back in the late 90s, but it wasn't Earth that was affected. A comet got stuck in orbit around Jupiter. One day, it got too close, and Jupiter's immense gravity broke it apart, turning it into a bunch of pieces. Some of them were as big as half a mile across. Scientists were curious because they didn't know what would happen when those pieces hit the planet. And in July 1994, the moment came. The comet's broken up pieces started crashing into Jupiter, one after the other. Over 6 days, 21 chunks of the comet smashed into the planet at insane speeds, like 37 miles per second. That's more than 130,000 miles per hour. The impacts were so powerful that they heated up Jupiter's atmosphere to a mind-boggling 53,000 degrees Fahrenheit, which is way hotter than the sun's surface. When each chunk hit, it sent massive plumes of material flying out of Jupiter, like when you throw a rock into a pond, but way bigger. Some of these plumes shot up almost 1,900 miles into the sky. Afterward, big dark scars appeared in Jupiter's atmosphere, and they stayed visible for months as the debris spread out across the planet. But this wasn't just a cool space event. Scientists actually learned a lot from it. Those dark impact marks helped scientists track the winds in Jupiter's stratosphere. The crashes even caused temporary changes in Jupiter's glowing auroras, showing that the planet's magnetic field was affected by particles from the explosions. Plus, the comet fragments didn't just make a mess, they also left behind new chemicals in Jupiter's atmosphere. Plus, some chemicals were also exhumed from the lower atmosphere. Some molecules like ammonia broke down over time, but others, like hydrogen cyanide and water, are still floating around Jupiter today. This helped scientists understand how different chemicals react and mix in Jupiter's atmosphere. Comet Shoemaker-Levy 9 was a wake-up call. It proved that massive space collisions still happen in our solar system. That's one big reason why NASA started looking into how we can track and prepare for any future impacts that might threaten Earth. Whether it's learning more about asteroids and comets, or about how giant impacts shape planets, the importance of such discoveries is undeniable.
Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the Earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed 2 sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, The physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin, brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom! It speeds up, suddenly racing forward really fast, almost as fast as sound. And that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal, fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing crack patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia subduction zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors. And in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for two quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see two huge ones happen close together. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.